He's going to walk over how to build a ChatGPT like clone in JavaScript. We're doing one next week on SQL and how to query SQL with language models. And then we're going to do one the week after that with yet to be announced guests, but we'll announce that on Friday. Was here. I think he's coming back shortly, hopefully, because he'll be doing most of the interesting talking here. And so, yeah, so for the focus of today's session, basically what we're going to walk through is how to create a ChatGPT like clone in JavaScript. And so why these two things? The ChatGPT like stuff, I think that's been the first major kind of application that we've seen come out of these language models. Everyone has proprietary data. And there's different ways that people want to interact with it. But the main one is chatting over it. And so ChatGPT over your data has been one of the main applications that we've seen. And then why JavaScript? Well, so we recently released a TypeScript and a JavaScript package. And this has been really exciting because we've seen a whole new set of users come in. And Maya's been doing a bunch of great work there, highlighting a lot of questions. And I mean, if we're being honest, the package is a bit newer than the Python one, so there's more rough edges, and has been helping out a bunch with that. So really excited to have him here today. Really excited to be going over all of this. This will be recorded. We will do 20 to 30 minutes-ish of a demo, and then we'll just take questions from you guys for the remaining time. So if you have questions, there's actually a dedicated Q&A channel, and we'd prefer that you use that rather than the chat channel, just to separate the two. But yeah, really excited to do this, and yeah. Maya, are you ready? Do you want to give a brief introduction of yourself or just jump right into it?
Yeah, can you hear me?
Yep.
Cool. Yeah, I mean, we've spoken about this, but I was probably one of the very earliest users of LangChain. I had a major issue where I was building an application where the person I was building for wanted to summarize YouTube videos that were, long, 3 hours, 4 hours, 5 hours. And I just remember spending just sleepless nights trying to figure out how do I chunk this thing, right? Because the context window issues. And it was just very expensive as well at that time to basically send all these API calls, and then each of them was just costing a bomb. And that's when I just stumbled across the repo and haven't looked back since. So here we are today. And yeah, so hopefully, we can cover, mostly answer most of the questions people have. I'll try and show a demo as well. And, you can just jump in and talk. We'll talk through it. But I think one of the first things, I'm just going to start with just an overview of the architecture in terms of just showing the visuals, and then you can just chime in as I go through.
Sounds great.
Cool. So let me just get that going. Just let me know if you can see my screen.
I can see it.
Yeah, hopefully everyone else can see it. And I think this video is also recorded, right?
Yep.
Cool. So in a nutshell, the first thing we want to kind of talk about is what is LangChain, and what problems is LangChain solving. So I just gave an example of myself personally where I was trying to build an application and it involved dealing with text that was very large, right? This is text that's beyond the context window, which is about 3,000 words. And if most documents we're trying to deal with, most data we're trying to deal with is much bigger than 3,000 words. And so one of the things that LangChain helps with, one of the problems that it tries to solve, is this splitting of text into different chunks that we can then send to OpenAI to get a response, right? So let's say you have a 50-page PDF, or you have a ton of CSV files, or you could just have a directory of different files. What LangChain has is a bunch of different loaders that would basically assist you.
It might be good to zoom in a little bit. I think some people, including myself, are having a bit of trouble reading some of these text box.
Not better?
Yeah, that looks great.
Cool. So how do we, just give me a second. Let me switch from my tab to my window so that I can just jump over to another example real quick. Just give me a second. Let's go through. All right, I will just share my window. All right, is it clear now?
Yeah.
Cool. So what LangChain has effectively, these are the documents here for JS, is a bunch of these things called loaders. What loaders are effectively is they take different formats of text or different formats of documents you have and convert that into text, which you can then store in a vector, store, retrieve, and use for the response you want. So let me just show you a quick demo of what this looks like in real time. So LangChain already has a chatbot at the top right here. So let's say you come in here and you say, okay, how do I build a chatbot for a 50-page PDF, right? You ask the question. And so what happens is the chatbot will basically say if it cannot find what it's looking for, it'll give a best estimation. And then let's say you follow up and say something that it knows about. So you can say, okay, how do I split the text of a large document? Okay. So if we press enter, we should see at this point that it then gives you a bunch of functions. It also gives you reference documents as well. So you can see, looks like this is what you're looking for can be found here. And you can see it's got verified sources as well, right? So not only do you get a response, but you also get the sources as well from what you're looking for. So this is just a brief demo of what's possible. And if you can imagine this for your documents or document or application you're trying to build for someone else. But what's actually going on under the hood is what we want to cover today. So if I jump back to diagram, what LangChain does effectively is it takes your documents, it loads these documents. So these are the document loaders that we spoke about. So you've got loaders for CSV files, JSON, PDF, text files. So let's say you had a PDF file, you would just run this function, and this function will effectively split the document into chunks. So you would have chunks of text, and each chunk you can define. So what LangChain lets you do, for example, is you have these things called text splitters, which should be
they're in the indices tab.
Indices tab, right? Here we go. So when you split a text, you basically split by character lines. But what's pretty cool is you can specify, you can say, I want to split by 2,000 characters and overlap. So overlap means that it basically controls how much of the text overlap between each chunk, right? So you can split, say, a 50-page PDF or a bunch of markdown files into chunks of 2,000 words. And those chunks are going to constitute these different chunks in here, right? Now, once we have these chunks, what we need to do effectively, create these things called embeddings. So if I zoom out a little bit, what are embeddings? So embeddings are basically just number representations of text, right? So you can kind of think of them as basically floating point numbers, the decimal numbers, and each decimal number is a representation of a dimension, right? So the best way to explain it very, very simplified is imagine you've got 3 texts, right? So one is a lion, one is a pet, and one is a dog, right? And we can represent these in these vectors or these embeddings, right? Now, let's say we're working with the 2 or 3 dimensional view of all of this. Well, we can see obviously that when we plot this, these vectors, that the line is far off, right? Because what this is saying is, okay, the pet and the dog have more similarity to each other than the line, right? So this is effectively what happens when you're doing a when you do these things called embeddings. All we're doing is turning this text into these numbers, which we can then compare from one to the other, right? So these embeddings are then stored. So first of all, we will then create these embeddings from LangChain's OpenAI embeddings. So we have the embeddings here. So OpenAI has an embeddings function, which effectively takes chunks of text like this, and it returns a bunch of numbers that look like that. But it has one, instead of just 4 dimensions here, it has 1,536 dimensions, right? So you have those 1,536 dimensions for that particular text that you store as a chunk, right? So you have the chunks, then
Oh, looks like there's maybe a freeze on Mayo's end. While we're resolving that, I've seen a few questions in the chat about some stuff around document loading and splitting text, which I think are really good questions, and there's a lot of nuance here. So I'll try to speak a little bit about that. First, the document loading. So these are all these are all contributed by the community. Okay, there's a lot of documents that you could possibly want to load things from, or a lot of sources that you'd want to load documents from. So you could you could load things from the internet, you could load things from local files, you could pull things from PDFs, and so a lot of the loaders in LangChain are contributed from the community, because oftentimes, there's this such long tail of places where you could possibly want to load text from, that it's tough for us to add them all. So we really rely on a lot of people to add and share their own document loaders with other folks. There's also a bunch of really cool companies that are doing this as a more focused effort. Like obviously, like this is just one part of LangChain, and so we want to integrate and play really nicely with those companies as well. So one in particular is Unstructured, and so Unstructured is mostly Python based, but they're releasing a kind of like hosted version of their platform, which will let or they're releasing like a non kind of like in memory version of their platform, which will let people use it from JavaScript as well. And so we're really excited about that integration. That should unlock a lot of different document parsing types. So they have support for HTML, Word docs, PowerPoints, everything like that. I also saw a lot of questions around text splitting. And so I think, this is another kind of like nuanced point. And so first of all, like why do we even need to split text in the first place? We need to split text because we need the overall documents by themselves are too big to feed into the model by itself. I'm going to take a second to put myself back on the screen. All All right. Okay, so we need to split these documents because there's this, we need to split them into chunks that we can pass to the language model. So how do we split them into chunks? The naive thing to do is basically just go like, every 1,000 characters or 1,000 tokens we put in this chunk, the next 1,000 tokens we put in another chunk, the next 1,000 tokens we put in another chunk. What are the downsides of that? So basically, that means that when you're passing these chunks to the language model, it may not have kind of like the full amount of information that it needs, or it may not have the semantically kind of like meaningful parts together. So I saw a question about splitting a PDF into chunks based on page or based on pairs.
I know if you, I just kept talking. I didn't realize the thing went off.
Yeah, we lost you for a bit,
maybe you can just carry on. I was actually just going through the diagrams to explain how things work under the hood, but you can just carry on if you want to.
Yeah, I'm just finishing up some stuff on the text splitting stuff.
Okay.
So yeah, but then after that, happy to go back. So basically, the idea of splitting text is you want to create like meaningful chunks, and so splitting it by page or splitting it by paragraph is a pretty good way to do that, because that's generally what like we as humans kind of find semantically meaningful. There's also obviously some information that's translated between paragraphs and between pages, and so you may want to do something with like the chunk overlap there. And so, yeah, I think there's a lot of nuance in defining these chunks. So by default, we use something that kind of like first tries to split by paragraphs, and then split by sentences, and then split by words, and then if it needs to, split by characters. But we also have more fine-grained ones. So for Markdown, we have a Markdown specific text splitter that splits based on like the different headers and things like that. And then for Python, we have a Python specific text splitter if you're like reading code files, and that splits by basically classes and then methods and then lines within that. So yeah, we don't have as many variations of text splitters as opposed to like document loaders, for example. But I think that's an under kind of like invested in area. So if people have ideas for like different types of text splitters, would love to get those contributed and get those shared with the community. I think there's a bunch of interesting stuff to do there. That's pretty much all I wanted to say. So Maya, if you want to take back over.
Cool. Yeah. Maybe just make some ad libs as I'm talking, just to so I make sure that you're here and everyone can still hear me. So what was the last thing you heard me say before I dropped off?
I think you were talking about putting them in a vector store.
Okay, cool. So let me just go back to share my screen. Okay, can you see the screen?
Yep.
Okay. So this is where the last part you heard me say about just storing in the vector store. Did I go? Yep. Did you see this section about the embeddings?
Yeah, we did the embeddings part, and then you jumped back up to talk about putting the embeddings in the vector store.
Yeah. So yeah, I was just saying that once it's in the vector store, these things called the vector store is just a place where you store the basically these number representations of your text, right? So you have different choices. There's pros and cons of each one, which we can talk about later on. But once you've chosen what vector store you want to work with, you're pretty much good to go. So this phase is known as ingestion, right? And it's just a phase of effectively transforming your documents into numbers that the computers can understand. So what happens when a search is made, right? So this is a very brief, just quick overview. So let's say with this example here, we have the lion, the pet, and the dog, right? Now, before I go into this, intuitively, if someone is going to use the word cat, right, it should have similarity with pet and dog, right, without even seeing the numbers. So what happens is we take the query, so this is cat, we transform this into an embedding, which you understand now. In this case, it would be OpenAI's embeddings. And then we create these vectors. Then now we go into your vector store, wherever you stored it for. And we basically say, hey, we have this new thing called cat, and these are the numbers that represent cat. Can you please respond back with anything you have that's similar to it? It goes in, it checks, it runs some calculations. I'm not going to get into that, but effectively returns back text that is similar. Chase, can you still hear me?
Yep.
Cool. So now we're going back to, if this all makes sense, then let's go back to a typical case, right? So what LangChain does effectively is this entire process, you can imagine, I'll just scroll down here a little bit, which we'll come and revisit this. This entire process, which is also up here, LangChain basically makes it much easier, much faster for you to do it. For any documents you have, or the vast majority of file formats, it makes it much easier to do. So it solves this problem of the context window. If you've ever tried to copy paste into OpenAI's ChatGPT, and you've got a large document, and then you just try and copy paste the whole thing, well, obviously it's going to say it's too big, right? Also, if you try and ask ChatGPT questions about your document, you say, okay, tell me, what does this employee handbook have to say about the policy for XYZ company? Well, the GPT doesn't know anything about your company because it's trained on a data set that, first of all, it's pre-2022, and also it doesn't have that data. So it doesn't have knowledge of your data. It has character limits. Fine-tuning is expensive. Then you have the issue of memory. How do you keep track of previous conversations as well? So LangChain helps to resolve all these issues through the different tools you can see here. So we went over the document loaders, the indexes, which are the stores. You've got a chain, which is just effectively what I showed in Dart, which I'm going to go into in a second. You've got agents, which Chase can also talk about as well, but effectively you can think of it as your personal assistant that goes out in the world and interacts with other tools, maybe other APIs. And then you have a chat, which is basically using the new GPT chat models for your application as well. And all of this, which you would have had to figure out, which I had to figure out on my own, the painful way, last year, it's just so much easier with LangChain. So if I jump in to this diagram, this is effectively what the vast majority of chatbots are going to end up using. This is the architecture of a chatbot. So you basically have a question. So how do I purchase a premium plan? This is a question to your document, right? And this question is effectively combined with the history. So if you've ever used ChatGPT, you notice that you can ask questions, get a response, and then ask another question based on the previous question, and then you have a response from that context. Well, how is it able to do that? Is because it takes the chat history, and you're able. What LangChain does is it can take the chat history, combine it with a question, create a standalone question. So basically, the prompt would be something along the lines of, given this question and the chat history, create a standalone question based on this topic or context. Then you take that standalone question, we go and run through this process here, right? Where we embed that question. Remember, like we took the cat, we embedded the cat, we got the vectors, went to the store, retrieved similar things, and then got a similar result. So that's literally what's happening here. The user's made a question about your document. We create a standalone question. We check for relevant docs. They're embedded in your store, wherever you want to store it. You can even store it locally if you want to. You don't have to use hosted solution. We get the relevant docs. We combine the standalone question with the relevant docs. You get the GPT to basically generate a response based on the standalone question and relevant docs, because you're providing these relevant documents as context. That context is going to result in an answer. So the answer is going to be something like, to upgrade to a premium plan, please go to this URL. And so we saw that example. We saw something similar when we came here, and we said, how do I split a document into chunks, or how do I split a large document into chunks I can embed, right? And so this is basically what's going on beneath the hood. You made this request, right? This request effectively went through this process. And if we jump back in and say, okay, maybe I don't understand something. So I say, okay, what do you mean? So what do you mean by chunk size? Press enter. We're going to see that it's going to remember the history of what we said. And I can go back and say, okay, can you explain what a text splitter is based on the first response? So we press enter again. Now we're going to see a response back. The reason it's able to do this is because, like I said earlier, it's going back in history, and each time a question is made, it's picking up from the previous history. So you just get a stack of chat history with the new question, create the standalone question, then you get this response that comes back. Chase, you can still hear me?
Yep, you're good. And so, yeah, so I might jump in here with a few comments if you want to zoom back out to the larger architecture. And then I'm seeing a bunch of questions as well. So so maybe we can transition to some of those after. But I think the first thing that I wanted to highlight is this is the kind of like creation of the standalone question and why we do that. So that's kind of like done for two purposes. The main purpose is looking up relevant documents in the vector store. Basically, the issue with could you stay on the diagram, Maya, by any chance?
You want me to zoom in?
No, if actually zooming out is maybe even better, just to get a whole sense of it.
Okay.
But basically, so you've got the chat history. So we want to look up like relevant documents, and so we need some query or we need some embeddings to look up against the document store. And so one option would be to embed the most recent question. But if that references previous things, then you're getting the embedding, you're getting the numerical representation for something that doesn't have the full context of what it needs to look up. Likewise, if you embed all of the chat history and the new question, if the new question is completely standalone and doesn't use anything in the chat history, then you're getting some kind of like no longer relevant parts that are now in the embeddings. This isn't the only way to do this, by the way. There are definitely other techniques that you could use. So rather than rephrase the question, you could you could look up documents based on the question and then documents based on the chat history and combine those. That was an approach that I tried as well. You could also look up, you could also do some sort of like logic to determine which of the previous responses are relevant. Maybe you could even use embeddings for those. So, take the new question, create an embedding for it, look at previous things to see if they're relevant, and then pass all of those as the final embedding. That I haven't tried that, although I would worry a bit again there about the like pronoun and the referencing stuff. So yeah, I think I just want to highlight that that is just one particular way of doing that part. And I think there are a lot of other ways. Hopefully, LangChain provides a bunch of the modular components that can be used to do those other ways, but we also provide this kind of like end-to-end way of constructing and querying the vector store for related things. And then another question that I've gotten a lot is basically around like the idea of like sources in the answer. And so there's like two things that you want to keep in mind when trying to get the language model to reference sources. One is it has to have access to the sources itself. So if you don't tell the language model what the sources are, there's no way that it's going to know what the sources are. And so this means that when you're passing the documents into the prompt, you need to, one, have sources associated with those documents. If you have, and those sources need to be what you want to be cited as sources. So if you're trying to cite a specific web page, you want to have that as the source. If you're instead doing like question answering over a YouTube video and you want to sort of cite the like minute mark or something like that, you need to have that somewhere in like the metadata of the document. And then once it's in the document, that needs to be like put into the prompt. And so a lot of the prompts that we have do this by default. They'll look for a source and they'll put it in there. But you can also change these prompts. And by source, I generally mean like a specific key in the metadata called source. But you can edit those prompts to pull in like more things. So besides just a single source key, you could also pull in other things. So for example, if you're, and I'm going to zoom back into, I'm going to zoom back in off the screen because I don't think mine is sharing anymore. So yeah, if you're doing like question answering over a book and you want to cite like the chapter and the page number and everything like that, then you want to have those different components somewhere in the metadata and be pulling those into the prompt. So I think those are the two things that and then also in the prompt, you want to tell the language model that it should cite its sources. So if you don't tell it, it probably won't do it, or it will do it erratically or something like that. So it's pretty important to tell the language model, hey, make sure to cite your sources and stuff like that. Maya, is there anything you wanted to add before we transition to questions?
Well, I mean, we just look at time, but I guess it depends if they want to go into the code or they just want to go straight into just more Q&A. So I guess let's just scroll through the questions. I think this just seems to be more interest in getting answers from you. So we can go either way. Maybe I could just do a brief code overview and then we can just go back to Q&A.
Sure. Let's do a code overview for like like 3 or 4 minutes or something like that, and we'll include a link as well because I imagine it might be hard to look at it live. And then while I was doing that, if people could go to the questions panel and just upvote ones that they'd like to get answered, we'll probably go through them in that order. And so there's the Q&A tab, which is below the chat box on the right of your screen. And so please, upvote questions that you want to get answered, and we'll prioritize those.
Cool. Let me share my screen again so we can try to do that. Okay. Share. Okay. See the screen?
Yes, and let me spotlight that.
Is that fine?
Yep.
Cool. So yeah, this is just more code representation examples of very basic components, if you want to say, of LangChain, which I covered in the diagram, which effectively got your chains, your agents, your document loaders, your memory prompts, indexes, and then you also have the splitters and the other things that we discussed earlier. So basically what's happening here is we're just going to run through different examples. So just to show you how much easier this is, what LangChain has is basically the models that you typically have to install. So let's say you wanted to use OpenAI, you would just simply get OpenAI from LangChain LLMs, which is basically a you can go in here, you can choose from Cohere, you can choose OpenAI. So it does give you different choices. So you can swap in and out, and that's a really good thing too, is if you do change your mind about any external services you're using, you can just swap in and out. So in this case, we just have a template, which is just what capital city of the country, then a new prompt template. So a prompt template effectively is a way that helps you to structure your prompts. Now, this is a bit of overkill here because I don't need, because the prompt is so basic, where you pass the template and then you say you want this thing here to be the input variable. This will typically come from a user. So in this case, the country, which will be passed here. But imagine a much more complicated situation where you're dealing with large documents and you want to have specific prompts for different users, or you just want to have a lot more complexity of variation. Prompt templates are useful because what they do is effectively allow you to almost create these inputs, these variables for text, right? And so if I was to run what the prompt looks like, so let's see if so I can run, and we are in chains. Yes. I think I'm in the wrong folder. Run. Yeah, Chase, I think I'm targeting the wrong directory.
Okay. I think what may be interesting is if you want to show the prompts that we use for the question answering, actually they're a little bit simple, but I think it'll be instructive to see how they're put in. So if you want to go to this is a different repository.
Right. Okay. I'll jump into the repo right now. Just give me a second.
I'm also happy to share my screen and jump through them as well if we're just looking at like the prompts.
Yeah, you can go ahead. That's fine.
Yeah. All right. So all right. So can you guys see this? I'm going to assume that's a yes. All right. Cool. So yeah, so this is the entire prompt that we use for the question answering bit. And so you can see that like here is where we tell the language model to use the following pieces of context. And so this is where we put all the pieces of context into one prompt. So we put it all into there, and we tell the language models to use it. This is where we tell it. I saw a question about how do you stop it from hallucinating. This works generally pretty well, where you basically just tell it to only restrict it to this information, and if you don't know, just say that you don't know. Don't try to make up an answer. And so yeah, it sounds a bit silly, but whenever there's questions about how do you get a language model to do certain things, it's generally you kind of ask it, you tell it not to. This is the context, and so this is where the docs will come in. And so this is put as a variable in between curly brackets, because basically this is going to be different for every question. And this is where like the idea of like retrieving relevant passages and putting them in comes into play. So this is something that's not hard coded. This will vary on runtime. Same with the question. So that comes in during runtime, and then helpful answer. And so this is just prompting the language model to return a helpful answer. There's some really interesting work here that maybe is probably less relevant with some of the chat models, but with a lot of the old language models, they basically, or even with some of the existing chat models, if you can put words into the language model's mouth and make it think that it's already started talking a certain way, it will kind of like continue talking that way. So by putting helpful answer rather than just like answer, we're kind of having the language model pattern match that it's giving like a answer that's actually helpful, and this is actually produces kind of like better results than just having like answer. This is maybe a little bit less relevant again with some of the chat models, but this prompt was optimized for just generic models. We can see below, and this is a prompt that's optimized for chat models. And so I'm happy to chat more about the specifics of differences between like chat models versus regular models. But here we have the exact same prompt. And so this is used as the system template. And this is just saying, this is like the instructions for the language model. And then we can see that we have a human message prompt template, and this is just with the question. And then we no longer have the helpful answer, and that's because with the existing ChatGPT API, you can't actually ask the language. All new messages are new messages, so you can't actually have the assistant start talking, or you can't put words in the assistant mouth, so to speak. And so I just wanted to show these as kind of like pieces of code for what the prompt templates look like. And then if we look at some examples, so I think there should be some examples and this is all in the LangChain JS repo. And so I would come over here and look for some if you want. If we look in chains at something like question answering, and actually this is just over regular documents. So let's look at like vector database question answering. So this uses the vector database. We can see here that it's like 25 lines of code to set this up and run this. And so specifically first, we're initializing the language model that we want to use. Then we're using, then we're reading in a document. And so we're not actually using a document loader here, just for kind of ease because it's a simple text file. Then this is splitting it up into chunks. And so we're using the recursive character text splitter. And so this will split it. This is the text splitter I was mentioning before that splits it up into paragraphs and then sentences and then words. We're creating documents. And so documents are a pretty simple concept. They're just text and then associated metadata. So here, because, and by metadata, what usually goes in metadata is like source. And so here, because everything's from the same file, the source will be the same. But that's generally where that would go. Then we create the vector store, and we also pass in embeddings. So this is saying, hey, use OpenAI embeddings, create this type of vector store from some documents, and then we initialize the chain. And so we give the chain the model and the vector store because those are the two levers that people most often want to control. You can also pass in custom prompts. So if you want to instruct the language model to respond in a certain way, you can pass this in this method as well. And now we can call kind of like the chain over these documents. I know we're a little bit short on time, so I'm going to stop sharing there. And I think now is probably a good segue into the questions.
Chase, I can show a live demo of a finished product if you want, and then you can jump if you want to do that, or if you're pressed in time.
If it's going to take a minute, let's do that. But we're down to 14 minutes, so let's.
Yeah, literally, it's just going to be a minute. So let me just show you that real quick. Yeah. You see the screen?
Yep.
Cool. So if we had more time, but we don't, but effectively what happened in this case is what we're able to do with LangChain is imagine you've got loads of documents somewhere. So in this case, it's in Notion. And each document, in this case, we're using Cron. So Cron is a calendar app. They've got support documents in here. So each section has text and each page has text inside as well. And so what we're able to do is use LangChain. For example, if you can imagine a document, you have loads of pages and loads of words, where you could just say something like, how does cron work? And we basically run through everything that Chase just said now, where it goes, it does the Q&A, combines into a standalone question, goes into the vector store, and then just gives you a response. So obviously we're short on time. I can't show more of this, but again, just showing what's possible alongside the chatbot you saw in the LangChain docs. That's it.
Awesome. All right, and then so I'm going to bring and we're joined by Nuno as well. Oops, I can't seem to figure out how to add all three of us onto the big screen. So I'll put Nuno on the big screen. So Nuno's been leading a lot of the development for the JavaScript package. And so has probably knows more about the JavaScript package than anyone else. So we're honored to have him here. Let's go to the question and answering. So I'm just going to go down by the order of what's upvoted. So if you want specific questions to be answered, please upvote them, and I'll probably defer to you for a bunch of them. I think the first one deals with oh, awesome. All right, we're all on the big screen. The first one deals with 3 ways to filter data in Pinecone: index, namespace, and metadata. The Pinecone store from existing index. So we don't intend to kind of like fully replicate all of the vector stores kind of like functionality in LangChain. Like we kind of wrap it. And so I'm not 100% sure what the status of the current implementation is. I know in the Python one you can use metadata to filter. I know there's been some updates to the client Nuno recently. I imagine this is maybe something that's just on the backlog but hasn't made it in yet.
Yeah, so this is a feature we can basically easily add. It's not there yet, but it's definitely something we can add.
Cool. The second one's about reducing hallucinations. Yeah, so I think just instructing it to pay extra close attention to the documents and not make stuff up is generally what I do. Have you guys seen any other kind of like tricks for reducing hallucinations?
Someone said they lost you, Chase. I don't.
Oh, can you hear me?
I can hear you, but someone said they can't hear you.
Okay, I think we're good. Do you guys have any other tricks for kind of like reducing hallucinations besides telling the model not to make stuff up?
Well, I guess depending on the use case, sometimes reducing the temperature can also help. Or some of the other more exotic parameters. I think just what you're saying about putting it in the prompt is usually the best solution.
Yeah. Cool. Is there a way to log out all API calls in their entirety from an LLM model for JavaScript, TypeScript? Nuno, do you want to tackle this?
So we added the callback manager functionality 1 or 2 days ago. So that's going to be your best bet for achieving that. So you can now subscribe to a bunch of different events, including LLM start, LLM new token, LLM error, LLM end, which should give you all the detail about all the calls that go in your models, as well as a bunch of other events throughout the whole library. So just really check that out.
Do we have a link for that we can maybe drop in the chat? Because this is one question that I get asked a bunch, and
I think it's in the documents, right?
Yeah, let me find that.
Yeah, let's drop that link in here. So I get this question a bunch because you've got these like complicated chains and these complicated prompts, and it's kind of tricky to know like what's going into where and how they're all constructed. The main way that we had to deal with this is, so we have this idea of callbacks, which basically get run on the start of an LLM call, and the end of an LLM call, as well as the start of a chain call, end of a chain call, and stuff like that. And so for logging, there's generally like 2 ways that we've seen people want to log things. One is to like the console, and we call this, I actually don't know what it's called in JavaScript, but in Python, we call this the standard out kind of like callback handler. Is that what it's called in JavaScript as well? Or?
JavaScript, it's usually called just console.log.
Something similar.
But yeah. I think either
All right.
name work.
Yeah.
So we have a callback handler that logs things to the console, and then we also have a concept of like tracing. And so this is this uses so this is a separate like platform that basically logs all these things and displays them in a UI for you to kind of like click through and look at. And so both of these were recently added as of like a few days ago. And so that's why it's so exciting. And I think, yeah, if Nuno can share it, yeah, awesome. Yeah. And so, just shared a link, and I would definitely check that out. This is like one of the biggest questions that we get, and this is a new feature that we're really excited about. So check that out. How to split a large document per chapter in order to do embedding using JavaScript. Yeah, so this is so right now there's nothing that does this by default. This is one that you'd probably want to write some custom code to do. But this is one that, so this is something where there's like a long tail of possible ways that you'd want to split documents. And so we want and so like how do we think about this as a library? And so we think about this in two ways. One, we want to make things modular so that if you need to write custom code for some part, you can easily plug it in, because we recognize that there's a really long tail of use cases. We're probably not going to be able to cover them all, but we want you to be able to kind of like write custom code, but still utilize all the other parts. So we try to design the library and make it like modular as possible. And then the other thing that I'd say is that, I hope someone contributes this to the library. This would be awesome to get in. I think like, there's probably different ways to do this depending on the type of book or things like that. And so, yeah, I mean, I'd love for some example of this to get in, but unfortunately at the moment it's not. Another question about kind of like loading documents is, do we plan to support docx formats in the future? This will get for free when we do the unstructured integration. I don't know if I think we're still waiting for them on that, right?
Yeah, let me confirm the status of that.
But Chase, before we wrap up, I think one frequently asked question is about production deployment and the options for that. So maybe we can cover that before we head off.
What in particular?
I think people are just asking about deployment. Does memory work in deployment? Does splitting work with serverless functions? People talk about Vercel. I know Nuno, speaking to you, that edge functions and not the streaming effect.
Yeah,
it doesn't work with Vercel at the moment.
So I can quickly touch on that. Let me also add a link to the docs. There you go. So at the moment we support Node, but we're actively working on
so you can
other environments like Edge and Deno and even browser. So yeah, just keep an eye on it. It will come soon.
Yeah, and for so the memory part, I saw a few questions about memory and that with production. So right now we rely on that kind of like being managed outside of LangChain. I think there are we're considering kind of like options to make that more baked in, but I think like right now that's done kind of like outside of LangChain. We're going to be working on ways to like help. We're going to be working on at least like instructions for how to kind of like manage that and then hydrate the memory with previous things. So that's definitely on the roadmap. I would expect that in the next few weeks. But for fully kind of like managed memory, I think that will be a bit longer. That will be something that takes a bit longer to go through. All right, I'm gonna just go through some rapid fire questions. Thoughts on LLM based splitters? So I'm assuming this means using language models to split text themselves. I think language models are getting pretty good at a lot of things, so I think it's entirely feasible. I haven't tried it myself, but I like it in theory. How to deal if we have sensitive data and don't want to share info with third-party service. So there are So one, when using LangChain, like everything's run locally. So you're not sharing any data with us. The way that you'd be sharing it is if you're using like these models like OpenAI and you're sending data to them. I know they're working on ways to kind of like do private deployments of stuff. There's also like local models like Hugging Face that you could run locally. I think most of these have better support in Python, but you can run these in a separate Python server to the side and then kind of use these in LangChain. So I would recommend that. What is Mendable? Mendable is a great company. I interacted with those guys a long time ago, and they power the search bar and they're doing this like search natively for all kinds of like I think it's Docusaurus kind of like builds. So any site that's using Docusaurus for their documentation, they can jump in there. Under what circumstances we use index alongside LangChain? That's more of a Python question, so we'll probably cover that in the Python part. I'm interested in using an agent that interacts with the vector store. Specifically, would like to answer technical questions with cited sources augmented by specific knowledge provided by other tools. It appears the current agent implementation does not yet provide detailed sources for the information retrieved from the vector stores. This feature would be super helpful. Something around that. Yeah, so this is, I think this is something that there'd be two ways to do this. One, you could use like a question answering tool that cited its sources as a tool itself and then rely on that. But then you'd also probably want to change the default prompt of the agent to tell it to cite its sources. So by default, this is a generic agent. It won't know to cite its sources. It won't know that it should be doing that. So I would definitely change the prompt that instructs the agent what to do. And then you may also need to change the vector store implementation, however you're using that, to return the sources. Yeah, I think this is a bit more, unfortunately, I don't have a great kind of like surface level answer for this. This is a bit more in detail one, but I would definitely start by one, making sure the agent has all the information. And so like, yeah, making sure that the vector store is returning the sources and stuff like that. And then two, making sure that it knows to like cite its stuff. So I'd probably like make a custom agent in some regard. We are out of time. There's a lot of questions that we didn't answer. We have a Discord. We'll try to answer them in there. There's also other folks that can help answer them. This was a lot of fun. We'll do it more. So keep an eye out for more. We're doing one with SQL next week, and then we're gonna announce a pretty cool one for the week after that. Yeah. Any final thoughts, Nuno or Maya?
Yeah, first time mistakes, but it's all good. I mean, the main thing is, if people get an introduction, and there's always going to be follow-ups. And I think the main thing is people wanting to talk to you and get you to answer questions, because you're not the easiest person to reach. So hopefully everyone enjoyed this. Yeah, I look forward to the next one coming up soon. That's next week, Thursday, right?
Next Wednesday. So we'll try to do these pretty consistently on Wednesdays mornings.
Yeah, join the Discord, and before you jump off, let me just post the Discord link if anyone doesn't have that.
All right, and yeah, Nuno, any final words from you?
No, yeah, just we release new stuff every day, so just keep your eyes out for new features.
Yes. Is there a release coming today?
There is a release coming today with a whole bunch of stuff.
Oh, and Carlos, I love that suggestion of a channel for events. We'll definitely add that in the Discord so it's more easy to keep track of these. That's a great idea. All right, we're over time. Thank you guys.